In the years since Thomson and Rutherford, a great deal has been learned about atomic structure. Because much of this material will be covered in detail in later chapters, only an introduction will be given here. The simplest view of the atom is that it consists of a tiny nucleus and electrons that move about the nucleus at an average distance of about 10 to the negative 8 centimeters from it. As we will see later, the chemistry of an atom mainly results from its electrons. For this reason, chemists can be satisfied with a relatively crude nuclear model. The nucleus is assumed to contain protons which have a positive charge equal to their magnitude to the electron's negative charge, and neutrons which have virtually the same mass as a proton but no charge. The masses and charges of the electrons, protons, and neutrons are shown in Table 2.1. Two striking things about the nucleus are its small size compared with the overall size of the atom and its extremely high density. The tiny nucleus accounts for almost all the atom's mass. Its great density is dramatically demonstrated by the fact that a piece of a nuclear material about the size of a pea would have a mass of 250 million tons. An important question to consider at this point is, if all atoms are composed of these same components, why do different atoms have different chemical properties? The answer to this question lies in the number and arrangement of the electrons. The electrons constitute most of the atomic volume and thus are the parts that intermingle when a given atom greatly affects its ability to interact with other atoms. As a result, the atoms of different elements, which have different numbers of protons and electrons, show different chemical behavior. A sodium atom has 11 protons in its nucleus. Since atoms have no net charge, the number of electrons must equal the number of protons. Therefore, a sodium atom has 11 electrons moving around its nucleus. It is always true that a sodium atom has 11 protons and 11 electrons. However, each sodium atom only has neutrons in its nucleus, and different types of sodium atoms exist that have different numbers of neutrons. For example, consider the sodium atoms represented in figure 2.15. These two electrons, for example, are called isotopes. These two atoms are isotopes, or atoms with the same number of protons but different numbers of neutrons. Note that the symbol for one particular type of sodium atom is written. When the atomic number Z is written as a subscript and the mass number A is written as a superscript, the particular atom represented here is called sodium-23. It has 11 electrons, 11 protons, and 12 neutrons. Because the chemistry of an atom is due to its electrons, isotopes show almost identical chemical properties. In nature, most elements contain mixtures of isotopes. And it's called fluorine 19, since the atom has 9 protons.